3.3 parallel lines and transversals. So if you remember, we're going to do a quick review. Transversal, that trans, think about that transitive property, tran, that prefix of the word means across. So here, a transversal is a line that goes across two other lines. And today we're going to be talking about when we have a transversal going across parallel lines. We're going to have some special angle relationships. So we want to first review what corresponding angles are. Corresponding angles, corresponding means same position, so corresponding angles would be like angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. Alternate interior angles. Alternate means alternate the transversal, right? Alternate the transversal. And exterior means on the outside. So 1 and 8, and 2 and 7. Alternate interior angles would be inside alternating the transversal, so 3 and 6 and 5 and 4. Consecutive interior angles, so consecutive means in a row, so angle 3 and 5 and angle 4 and 6. Now, if two lines are parallel and cut by a transversal, then we come up with these first is a postulate, then we have some theorem. So corresponding angles postulate. Postulate's an accepted rule. The first one we're just going to have to accept. After that we can prove these. Later we will prove one of the other theorems. But if you think about two pieces of bread, are these parallel lines? If you take a knife and cut through those two pieces of bread, it kind of makes sense that the corresponding angles here, angle 1 and angle 5, basically that knife is cutting through the bread just like it cut up on the top as it's cutting the second piece. Angle 1 and angle 5 are going to be congruent. So the corresponding angles postulate and all these theorems start off with, if two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, and then I'm going to erase here. So then we have, leave that. Those are corresponding angles. Now the alternate exterior angles, 2 and 7, for example, are alternate exterior angles. And what I always say is all the acute angles are the congruent, and all the obtuse angles are congruent to each other. So angle 2 is an acute angle, angle 7 is an acute angle. They're going to end up being congruent to each other in this case, but they are alternate exterior angles. And this can be proved basically by, if angle 1 and 5 are congruent, you could show that 7 is a supplement to 5 and 2 is a supplement to 1, while 2 is really a supplement to 5, so 2 and 7 are congruent. Proof like that would work. Alternate interior angles. So if I went with angle 3 and angle 6, alternate interior angles are also congruent. So, and then just as you start to think you see a pattern going on, you talk about consecutive interior angles, and you look at your consecutive interior angles like angle 4 and angle 6. They're both on the inside. Are those both acute? No, one's acute, one's obtuse, right? This one's acute, that one's obtuse. These two angles are going to add up to 180 degrees. So that we're going to say all consecutive interior angles are supplementary. Okay, very important that you have these theorems memorized. If you understand what alternate exterior angles are, most of them, these basically, the acute angles are congruent, the obtuse angles are congruent, and if they're an acute and the obtuse, make them supplementary. That's kind of the key to the problem here. So here we're going to solve for x and y. They want us to find these variables. So I have to figure out a relationship between them. And I look at this, I'm looking at angle x and angle y, or angle x and angle y, and this angle here, and I'm thinking this is going to help me figure out what these angles are. So I look at this and I say, okay, these are acute angles. Actually, they're vertical angles. I know vertical angles are congruent. If they're congruent, they have the same measure. So angle x is 72 degrees. Now, how do we find y? Well, if we know x is 72, we can find y by knowing that these angles add up to 180. So y minus 8 plus 72 equals 180. If I simplify this, I would get plus 64 equals 180, and if I subtract 64 from both sides, I'm going to get y equals 116. And then I can double check my work. I feel like I might have made a mistake here. Hold on. 72 plus 116 does not add up to 180. Oh, but y is 116. So the angle's not 116, excuse me. That would make the angle 108. So 116 minus 8 is 108. 72 plus 108 does add up to 180. These angles are equal to each other. The other 72 degree angles would be here, because they're corresponding. And this angle and this angle are alternate exterior angles, so they're also 72. And then the other ones would be 108. They didn't ask us to find this, but it's good to be able to. 108. Perpendicular transversal theorem says if a transversal is perpendicular to one of two parallel lines, so we know these lines are parallel, we mark them with the arrows. If those lines are parallel and this line is perpendicular to one of them, then it's going to be perpendicular to the other. And here is that proof of the alternate interior angles theorem. So we want to show that, what are we going to prove? My alternate interior angles, angle 1 is congruent to angle 2. Let's prove that. Well, that's what we're trying to prove in the theorem. What are we given? Well, we can use that postulate. That's something that we just accepted already. The corresponding angles postulate would say angle 1 is congruent to angle 3. So to prove that angle 1 is congruent to angle 2, I'm going to start with my given, angle 1 congruent to angle 3. And we can say, it's not really given, I'm not going to use given, but it's the corresponding angles theorem. Or, I should correct that, corresponding angles postulate. That's the only postulate. The rest of them are all theorems because you can prove it using the corresponding angles postulate. Oh, you know what? I missed something. You guys are going to hate me again. But, like I said, I'm thinking another part of the alternate interior angles theorem is that these angles are, or lines are, have to be parallel. Okay, so we have to say P is parallel to Q. That needs to be given. Okay, so if P is parallel to Q, we know angle 1 is congruent to angle 3 by the corresponding angles postulate. This starts to make sense because you need the parallel lines, right? We also know angle 3. What else do we know about angle 3? Angle 3 is congruent to something else. Angle 3 is congruent to angle 2. These angles are congruent, and that's the vertical angles theorem. Okay, so the vertical angle theorem says all vertical angles are congruent. And now I can make that conclusion of angle 1 being congruent to angle 2. Why is angle 1 congruent to angle 2? Well, angle 1 is congruent to 3. Angle 3 is congruent to angle 2. We're going to go across the 3 to the 2, right? We're skipping over the 3. Think about the train. And that's a transitive property of segment congruence. And this is an interesting problem. I'm not going to actually do it here tonight for you. Something you could look up online. You could look up Eratosthenes. He was a Greek scholar, and he actually, in 276 BC-ish, calculated the circumference of the Earth using alternate interior angles. He came up with the circumference of the Earth within a few thousand miles. So you think about, almost 2,000 years before Columbus, he knew how round the world really was. It's a misleading thing that Columbus actually, people thought the world was flat back then. Only if you were really ignorant. Most people knew it was round, and he actually had a really good estimate of the circumference, way before planes. So kind of a cool problem. You can more than welcome to go back and do that on your own and look into it. Ask me questions tomorrow. Have a good night. There's your homework.